Hello everyone. Today I want to explain about the physical properties of alkanes. In the first point, alkanes are non-polar. They are having weak van der Waals force. Why they are non-polar? Because of carbon bond and carbon hydrogen bond, their electronegativity difference of carbon and hydrogen is very less. Therefore they are considered as a non-polar covalent bond. Therefore their dipole moment is very less. Otherwise we can say this is near to zero, but not exactly zero, because some molecules having some dipole moment. So keep in mind alkanes are called non-polar. Which one these are? Non-polar. Therefore they are divided into 1. C1 to C4 are gases. It means ethane, ethane, propane, butane. Up to butane are gases. So these are generally gaseous. This is gaseous. Next, C5 to C17 are considered as liquid, because when molecule size increases, intermolecular forces increases. Therefore C1 to C4 are gases, C5 to C17 are liquid. Then C18 onwards, their intermolecular force are very greater. Therefore they are, it means C18 and above 19, 20 all are considered as a solids. So keep in mind C1 to C4 are gases, C5 to C17 are liquid, C18 above are solids. Next, third one. In this, alkanes are colorless and odorless. So no color, no odor. Odor means smell, no smell, that is. Next, fourth one, density of these alkanes. Density formula we know, mass by volume. Density of alkane nearly 0.7 gram per milliliter. Then compare with the water, alkane density is less than the water. Water density nearly 1 gram per milliliter. Alkane density 0.7 gram per milliliter. It is less. That's why alkanes are generally float on the water, because lower density. Next, fifth one point. Alkanes have low boiling points and melting point compared to more polar compound of comparable size or comparable molar mass. Now I took here, one is propane, another is ethanol. If you consider its molar mass, I will write here molecular weight. Nearly carbon 3 are there. So 3 carbon mean 3 into 12, that is 36. And hydrogens are 6 plus 2, 8. Therefore 8 into 1, then this is 8. Then this is 44 gram. So this is 44 gram per mole. Then this is also nearly molecular weight 44 gram per mole. So nearly similar molar mass these are. So what we have to check first, check the forces. Here which forces is there? Van der Waals forces are present. Here every molecule has the van der Waals force. There will be van der Waals force present. And here dd means dipole force, because it has mu not equal to 0. It also mu not equal to 0, but very less. This somewhat higher considerable. Keep in mind. So this very less is negligible compared with the this ethanol. Therefore, their boiling point minus 42 degrees Celsius, here 21 degrees Celsius. It is lower, this is a higher. Melting point minus 190, here minus 121. So in negative terms, higher value, this is lower because it is negative value, lower, this is higher value. So those are having comparable molar mass. First we have to check the forces and what types of forces are there. If equal is there, then you have to check the next hydrogen bonding also. Therefore, increasing the strength of intermolecular forces, increasing boiling point and melting point. Next, sixth point, boiling point and melting point increase as the number of carbon increases because increased surface area. So first one we have butane, pentane, hexane. So carbon chain increase means surface area increases, but that should be in a straight chain. Therefore, surface area increase means intermolecular force increase. Therefore, boiling point, melting point increase. Now, according to this, melting point value 134.6, 143.3, 178.5 Kelvin, and this is melting point. Boiling point 272.4 Kelvin, 309.1 Kelvin, 341.9 Kelvin. So intermolecular force means surface area increase means intermolecular force increases. Therefore, melting point, boiling point increase. See here, increasing surface area, increasing boiling point and melting point. This is increases from left to right. Next, seventh point. The boiling point of isomers decreases with branching because of decreased surface area. So now we have how many carbons? C5, H12. This is an alkane general formula. It is called. In this, we have one is pentane, another is 2-methyl butane. This is called isopentane, neopentane, 2,2-dimethyl propane. This is 1, 2, 3. Second position we have the methyl, that's why 2,2-dimethyl propane. Now observe here, when straight chain is there, this much surface area. So we have surface area this much. But here surface area somewhat less. Here surface area less. Therefore, keep in mind when branches increase, that become more spherical. So when more spherical, according to mathematical, spherical shape surface area less than the a straight line like a rectangle type or like this. So keep in mind surface area decrease on increasing branching. Therefore boiling point will be decreases. Now observe here boiling point 282.5, 300.9, 309 Kelvin. So straight chain has a higher boiling point and branches has a lower boiling point. So increasing surface area, increasing boiling point. Next, eighth point, melting point increase with the symmetry. This is a pentane, 2-methyl butane, and 2,2-dimethyl propane. If you consider this one, then what happened here? This is a more symmetrical because methane with the same carbon, meaning a plane of symmetry present. So this is most symmetrical part. This is, and when symmetry increases, their packing will be increased. Keep in mind, if symmetry increases, then what will happen with packing efficiency increase. If packing efficiency increase, they are very close to each other. Packing efficiency increase, therefore they are very close to each other, then strong intermolecular force exists between them, therefore to break that required energy more. Therefore we know that branching increase, we cannot tell always there is a more symmetrical. Here it is possible, that's why you have to think always symmetry possible or not, then only you have to answer. So here symmetry increase, therefore melting point increase. Here you observe this is 143, this is 113, this is 256. But here in general I wrote here left to right increase, but you observe here that purposely I mentioned here this is lower. Compare with this symmetry is greater, that's why this is more symmetrical. So this is lower boiling point and melting point, this is a higher melting point. But in general left to right I wrote there increase, but it is not, because we have to check always symmetry. So in general, our mind, what is that one statement given that may be always correct. Therefore, to avoid that, here I want to focus here specifically, because branch increases mean always not symmetry possible. So you have to check here symmetry present or not. Therefore, now increasing symmetry, increasing melting point. Next. Next, what is here? Solubility. We know everyone like dissolves like. What is it like dissolves like? Similar nature compound soluble in the similar nature type of solvent. In that first one, alkanes are soluble in organic solvent. Organic solvents are generally non-polar, or we can say less polar. Therefore, alkanes are soluble in the organic solvents. Keep in mind, alkanes are soluble in which one? Organic solvent. This is important. What are the organic solvent? We know that organic solvents are C6H6 benzene and C6, or we can say toluene directly, C6H5CH3 and hexane and petrol. All these are example for organic solvents. Next, alkanes are insoluble in water because water is polar. Water is polar. This is so polar solvent. Alkane is which one? Non-polar, or you can say less polar. Therefore, it is insoluble in water. But keep in mind, carbon number increases, solubility what happened? In case little soluble also, that solubility what happened? Decrease. It's a very important statement you have to keep in mind. Last and final, petrol and lower fraction of petroleum solvents are used for dry cleaning clothes to remove the grease stain. What is a grease? Mixture of higher hydrocarbon. So hydrocarbons are generally less polar, petrol also less polar. So non-polar soluble, and it removes the grease stain. It is easy to, that's why it is used in the dry cleaning.